Hey guys, what's up? Today we are going to talk about traction circle. I know that we have talked about it earlier in one of the previous videos, but today it will just be very basic about it. No more fuss, no more things like, the best cornering line or anything like that. Just basically forces which we'll be talking about. So let us get started with this. Traction circle is, like the name says, it is a circle which shows the traction points that a vehicle can, that a tire can withstand. If the point goes beyond this circle, then hence the force is exceeding more than the tire can take, and the vehicle will lose its stability. So on y-axis we have the acceleration force and braking force. On the x-axis, we have the lateral forces which will be acting when a vehicle takes a turn. So how to plot this diagram? Well, we have resultant vector force which will be arising because of the Fx. Fx is lateral force, Fy is the longitudinal force. Like longitudinal forces are basically the acceleration forces and the braking forces. And yeah, I think I have mentioned this earlier right now that Fx are the lateral forces that will be acting while taking a turn. So again, like I said, the resultant out of these two forces, we get different resultants for different values of Fy and Fx. So hence, if we join all the vectors which we will be having by these two forces, we can plot a circle. Of course, in reality, it won't be actually a perfect circle, but this is an ideal case which we are talking about, and just for the understanding purpose, we'll assume that we are having a circle. So let us just say have this one value of Fy, one value of Fx, and the resultant can be achieved by we know the basic formula for getting a resultant vector out of two forces, fx square plus fy square, the entire the square root of the entire thing. And this force which we get is also equal to the basic traction force. We can say f equals to mu into mg. Mu is kind of the most important part when we talk about acceleration and braking, because whatever the forces are transferred from the wheel to the tire to the road surface, everything depends on the coefficient of friction that is present between them. So hence mu into mass of the vehicle into the gravitational acceleration. Like I said, Fx is the lateral force. So here it is, I just interchanged the places. My double dot, which is m mass of the vehicle multiplied by the lateral acceleration, and Fy square is the square of mass of the vehicle multiplied by longitudinal acceleration. Simplifying this equation further, we will be getting rid of the mass of the vehicle, and hence we are left with this term over here. So now it's kind of difficult to understand this, talking about the longitudinal acceleration, the lateral forces, and all that stuff. So let us understand this concept with an example. Let us say that I am traveling in a vehicle at velocity of 100 kilometer per hour. Oh, I've already mentioned it over here, 100 kilometer per hour. And I am driving through a circle which has a radius of, I'm driving through a turn which has a radius of 150 meters. So now I want to know what is the lateral acceleration at this point. So we know that whenever we are taking a turn, we have always come while talking about lateral accelerations, we have come across this term like centrifugal forces that is acting on a vehicle. So centrifugal force is mass multiplied by the velocity square by the radius of the turn. But here we are just talking about the acceleration. It's not, force is mass into acceleration, but if we get rid of the mass term, then we have the acceleration. So hence v square by r. V is the velocity of the vehicle, r radius of the turn. We need to convert this into meter per second, quite understandable, not the thing to mention. And hence we get a lateral acceleration of 5.14 meter per second square. This is the lateral acceleration. Now I want to know that, I'm taking a turn. I'm neither applying acceleration nor braking force. So hence my longitudinal forces are zero, and I'm just, I want to know the maximum allowable lateral acceleration. So hence I will be using this term. In this term, the value of x will be x double dot square will be zero because no longitudinal forces. So hence y double dot, which is lateral acceleration, will be equal to the value of mu. 1 is quite a good value, I must say. Well, in reality, it depends on the type of road surface and tires and all that stuff. But let us assume for this condition, the value of coefficient of friction is 1 multiplied by 9.81. We have this allowable lateral acceleration. Now, at this acceleration, we need to I want to know what is the maximum allowable velocity with that, Vmax, which corresponds to this lateral acceleration. So going back to this formula, which was the lateral acceleration formula, v square by r, taking radius onto the next side, we have these terms under the square root. Keeping this value over here, 9.81, and at the radius we have 150 meters, we have 38.36 meter per second, and converting into the kilometer per hour, we have 138 kilometer per hour. So without acceleration or without applying the braking force, keeping the longitudinal force is zero, we have the maximum allowable velocity through a circle, through a turn with having a radius of 150 meters. I can travel with a velocity of 138 kilometer per hour. So this was all the basics about traction circle. If we talk about motorsports, which that they use, the technology is on another level. They have a computer, they have a software which the forces on the tires are calculated. They have a test run. Okay, the vehicle will be performing a few laps, and the tires are monitored uh, you know, uh, very accurately, and all the forces that are acting on the tires, they are plotted on this computer screen, and the traction circle is automatically constructed over there on the computer using the software. So hence they can see the ability of the tire, and keeping that in mind, keeping the traction circle in mind, they can know what is the maximum force that a tire can withstand. But that's quite much into detail. We just wanted to talk about the basic thing about traction circle. So yeah, when now you know that when someone talks about traction circle, you need to consider this longitudinal force or accelerating and braking force, and the Fx, which is you know mass into the lateral acceleration. That's the lateral force. And with this simple formula, you can calculate the forces which are acting, and the velocity, the lateral acceleration, the longitudinal acceleration. Yeah, that was the basics of traction circle, and all for today's video. In I hope you liked this video. If you liked it, you may share it with someone who wanted to know, who was curious about traction circle, and I'll see you guys in the next video.